Hey programmers, Alvin here. Right now I want to go over a Python solution for this max root to leaf path sum problem. Alright, so hopefully you watched the approach video. If you haven't, highly recommend it because I'm going to jump straight into the code and implement that strategy. So like we said, I think the best way to solve this one is recursively, and I feel that way for most of our tree problems that deal with paths, right? And not every tree problem has you return like some type of path, right? But for us, we'll start with our base case because we're going to solve this recursively. And I'll think about the scenario, let's say when I have a root to leaf path, right? So I need a path to a leaf. So my base case is if my root is also a leaf, right? So if root dot left is none and root dot right is none, right? That means I basically terminated some path. What I want to do is return a sum, right? And the sum of that path would technically just be root.val, right? So I imagine if, let's say my current root was a number or a node that contained 4, technically I can treat that as if it's its own input, right? So I want to return basically the number 4. That way I can get my sum running. Cool. And after I return there, I'll think about my recursive case. So I know my recursive case is going to call the same function. That's what recursion is. And I have to figure out what I should pass in next. Not too many options here. You must pass in root left and do another call on root right. Now I'll think about what type I get back from these calls, right? I know they're going to give me back a number, right? A number representing the max path sum in my left subtree or the max path sum in my right subtree. Cool. And what I'll do is I'll just save those to variables. You can always just reference the call if you want. But I'm going to say, I don't know, max left equals that. Make sure you spell it right. And then we'll say max right equals that. And those are going to be numbers, right? So what I want to do is, all right, figure out with these values, how do I compute my answer as a parent where I am like the root, right? Well, it's about choosing the max. So I want to choose the bigger of my two children calls, right? So one way I can do that in Python is just to do, let's say, just max, and I'll pass in my max in the left and the max in the right. And I will just choose the bigger number between them. And what I want to do is just add myself to it. So I'll say root.val plus that. And that feels very consistent with the logic we took in the approach video, right? Just add myself to the bigger of my two children calls, right? And so with that, we're going to be missing a scenario, right? It could be the case that sometimes our root is going to be none, right? Imagine we were at a node like this one. If root was this 4 node over here, right? This 4 node would not hit the base case because it has a right child. And then I would run line 11. Line 11 would pass along 4's left, but 4 has no left, so it's none, right? And so that means later on when I run my code, I'm going to get an error, right? Because if I pass in none over here, then I hop into that call, and then I say none.left. Now I get an error, right? So whenever we have root as none, we want to treat that as basically still a number, but kind of ignore it for the sake of our comparison. So in this problem, since I want to find a maximum, I'm going to default root none. So let's say if root is none, then I'll just return basically a positive, or rather a negative infinity. Because if I return negative infinity, then I know it's never going to win when it's passed into this max call over here. So I'll effectively ignore it. But at least I'll keep most of the business logic of my code mostly the same, right? It's always about compatible types. So I'm going to return to represent a negative infinity in Python. You can say float and pass in a string of negative INF. Kind of funky syntax, but that's how you do it in Python, right? And so let's go ahead and give this a test run. See what we get. Run them test cases. Nice, and there we have a solution for max root to leaf path sum. So this is about the second time you've seen this like infinity or negative infinity pattern. And I'd say it's fairly common when it comes to like minimizing and maximizing, right? If you want to take a max, then maybe default to negative infinity. It's a good default value. And you do the opposite for our min value problems. All right, programmers, that's all I got for this max root to leaf path problem, and I'll catch you in the next one.